Today we're going to be looking at specifically triangles. In our case, we're going to be looking at the Isosceles Triangle Theorem and its converse. So basically, we have the Isosceles Triangle Theorem and the opposite. The Isosceles Triangle Theorem states if two sides of a triangle are congruent, then the opposite angles are congruent. So in this case, we can say if, and as the markings show, AC is congruent or equal to BC, then in our case, the two angles across from it, 1 and 2, are going to be the same as well. So they're going to be equal. So notice, as long as we have the markings, we can say the angles across from them are going to be the same as well. The converse of the Isosceles Triangle Theorem is the opposite. If I have two congruent angles, then the sides opposite the angle are going to be congruent. So the sides that are going to be across from 1 and 2 are going to be the same. So if angle 1 is equal to angle 2, then in our case, DE is going to be equal to EF. We can use that to our advantage to set up and solve equations algebraically. We can find missing side lengths. We can find missing angles. So let's see what that looks like. First off, we have to name the two unmarked congruent sides. So here we see that this angle and this angle are the same at ACD, and ADC are the same. So we can say the sides across are the same. So AC equals AD. And the unmarked congruent segments, same thing. I should move that around. These are the congruent segments. The unmarked congruent angles, here we have the two sides are the same, so we can say the angles across from them are the same. So we can say angle ACB is equal to angle ABC. Algebraically, we have these problems. We got to classify the triangle shown by its angles and explain our reasoning. So here we have angle measurements. In terms of x, we have no idea what they are. So the question becomes, how do I figure out what these angle measurements are? Fortunately, we learned in the previous lesson that if I were to add up every angle in a triangle, I'm going to get 180 degrees. So if I add these three angles, 15x plus 1, plus 4x minus 1, plus 6x plus 5, I'm going to get 180 degrees. So what I'll do first is I'll combine terms so that way there my life's a little bit easier. So 15x, positive 4x, positive 6x, add them all up, I'm going to get 25x. And then if I look at my solid numbers, I got a positive 1, I got minus 1, and I got plus 5. So when I add 1, minus 1, plus 5, I get plus 5, and that's still equal to 180. So what I'll do now is I'm going to solve for x first and foremost. So I'm going to subtract 5. So we get 25x. Gives me 175. If we divide by 25, I'm going to get x equals 7. Now that I know what the value of x is, I can plug it in for x to figure out what the angles actually are. So if I want to find out what this top angle is, I'm going to do 15x plus 1. We know x is 7, so 15 times 7 plus 1. So when I multiply it out, I'm going to get 105 plus 1, which is 106 degrees. So we know this angle up here is 106 degrees. From here, I don't have to really have to figure out the other two, because we learned as well when dealing with angles, if I have an angle that is over 90 degrees, we have an obtuse triangle. 106 degrees is definitely more than 90 degrees. So here we have an obtuse triangle. 2, we are tasked with finding the value of each variable. So I need to figure out what the value of y is, and I have to find out the value of x. First things first, let's look at our sides. We're told that these two sides are the same. And I know they're the same because we have the little slash in between them. So a single slash on each side here tells me they are the same. And when two things are the same, all I have to do is set them equal to each other. So 4y minus 2 is equal to 2y plus 2. So I'm going to solve for y. Here I have y's and numbers on both sides, so I want y to one side, I want number to the other. It's easier to always move the smaller values. So if I look at 4 and 2, 2 being smaller, it's going to be easier to move. So I'll subtract the 2y from both sides. And we get 2y minus 2 is equal to 2. Now that y is on this side, I need to move the 2 over, so I'll add 2, which will cancel those guys out. So we have 2y equals 4. Last but not least, we'll divide by 2, and we get y equals 2. So I found the first value, y. Now I need to figure out what x is. So here we have an angle. Here x is part of the angle of a triangle. So this angle is 6x plus 8. This angle up here is 80, and there's nothing over in this corner. What we have to do is figure out what is supposed to go over here. Remember, we have the two slashes here, which tells me the two sides are the same. I can use the Isosceles Triangle Theorem in order to fill in the blank here. And again, the Isosceles Triangle Theorem states if two sides are congruent or equal, the angles across from them are going to be equal as well. So if I look across from this side, I see this angle is 6x plus 8. If I come across further, I can say this angle is also 6x plus 8. Now I have all three angles filled in, and I can figure out what x is equal to. We know the triangle angles will add up to be 180. So we'll do 80 plus 6x plus 8 plus 6x plus 8. And I'm going to get 180. I'll combine our terms, so I can do 6x plus 6x. I have 12x. And then I can add 80, 8, and 8, and I get 96. Solve for x. X is already by itself on this side, so I'll subtract the 96. That should be 180. 96's will cancel out, leaving me with 12x. And that's going to equal, once I subtract, 84. Last thing I'll do is divide by 12. And I get x equals 7. So for this particular problem, we get y values of 2 when we set each side equal to each other, and we get an x value of 7. Letter B, same deal. We have triangle SRT. We have side measurements of 7, 9, and 2z minus 15. And we have these little markings here in the corner. Again, these little markings, these little arcs tell me the angles are congruent, or the same thing. This one, we would use the converse of the Isosceles Triangle Theorem. So isosceles tells me if two sides are congruent, the angles across from them are congruent as well. Converse states if I have two angles that are the same, the sides across from them will also be the same. So if I go across from angle T, I'm dealing with the side 2z minus 15. And if I go across from angle S, I'm dealing with 9. So these two sides are the same. And when two things are the same, all I have to do is set them equal to each other. 2z minus 15 gives me 9. Solve for z, I have to add 15. So I get 2z is 24. And I'll divide by 2. So z is going to give me 12. So again, we're just tasked with finding the value of the variable. So we found our variable z is equal to 12, and I don't have to go any further. C, we have triangle WXY, sides 8 and 8, angles 62 and 4x minus 2 with a little arrow. So this angle here is valued at 4x minus 2. Little mark, because we have the sides, if they're the same, I like putting little marks, so that way there I have something to go off of. Again, if I know two sides are the same, the angles across are going to be the same. So this angle and that angle are going to be equal. So because they are equal to each other, I just set up the equation. 62 gives me 4x minus 2. Solve for x, I add 2. And I get 64, gives me 4x. Divide by 4. And x is going to be 16. And letter D, we would be doing the same thing. Here we have this triangle. We don't have letters, but we don't really have to because it says all three angles are the same, and we know they're the same based on these little marks that they have in the corner. So we can say, because, and one of the general rules is if the angles are congruent, the sides across. So I can say this side with the 2x plus 11 is the same as this side with nothing, which is the same as 6x minus 9. So we actually have an equilateral triangle here. Because we have an equilateral triangle, all three sides are the same. If they're the same, they just get set equal to each other. 2x plus 11 equals 6x minus 9. Solving for x, general rule of thumb, make life easier. We move the smaller x. So if I look at 2x versus 6x, 2x is the smaller. So if we subtract 2x, they'll cancel out. It leaves me with 11. 6 minus 2 is going to give me 4 x's. Subtract 9. To move the 9 over now, we do the opposite. So add 9 to both sides. And we get 20. Is 4x. We're going to divide by 4. And value of x is going to be 5. And we can keep going through. It's going to be the same thing. Here we have two sides are the same, so this angle and that angle are the same, meaning I can plug in 3x plus 6 over here. Little square in the corner tells me we have a 90-degree angle here. If I add up all three angles, I'm going to get 180 degrees. So 3x plus 6 plus 3x plus 6 plus 90 equals 180. Solve for x. F, same deal. We got two markings here. So this angle x, 6y minus 2, is going to be the same down here. Gives us 4x plus 20. Now, we do have different variables in this case, but because they're the same, all I have to do is replace. So we know that 4x plus 20 equals 6y minus 2, and all we have to do instead is replace 4x plus 20 with 6y minus 2. Add these up. 52, 6y minus 2, 6y minus 2, and I'm going to get 180 degrees. And that is using the Isosceles Triangle Theorem and the converse of Isosceles Triangle Theorem to figure out different values of angle measurements and side lengths.